Okay, so today I will show you how to make this custom transparent Edgelit 7-segment display. And I really like the appearance. It looks like something from like the old sci-fi movie. And the best thing is that this is a very simple project. It's perfect for beginners. The inspiration for this project came from this video, which I have seen a long time ago. You can see it's like 10 years old, and unfortunately the links from this video are no longer working. But at the time of seeing that video, I didn't have enough knowledge and I didn't have the right tools to build my own version. Well, I think I have both now. Yeah, we will see. This video is sponsored by PCBWay. If you ever need PCBs or PCB assembly, or even things like CNC machining, 3D printing, or maybe injection molding, well, in all those cases, PCB has you covered. They offer all of those services for a reasonable price. And I was actually using a lot of those services in my past videos, and it was always a great experience. By the way, if you do need PCBs, you can use the link down in the description, and you can get 10 PCBs for free, only paying for shipping. So thank you PCBWay, and let's get back to our project. So the Edgelit displays are quite simple. If you take a piece of glass or acrylic or pretty much anything transparent, and I have this piece of acrylic which is supposed to be like a blank business card, and if you take that and shine the LED from the edge, you can see there is an LED hidden behind this sticker. So if I turn it on and shine the LED on the edge, the light will travel inside the acrylic and bounce around. And if you visualize the light path, it will bounce over the sides, and as a result, most of the light will be shining on the edges and a very little light will be shining on the back and front sides. However, this changes if you scratch or edge the front side, because then the light will bounce over this scratch, and as a result, this area will be shining much more. And that's pretty much how the Edgelit displays work. There is a YouTube channel called Friend Blanche, which shows a lot of those vintage and old displays, including this interesting Edgelit display. You can see how those acrylic pieces are bent, because the light source is on the back of the panel, because at that time, 50 years ago or so, there were no small SMD LEDs, so the light bulbs has to be used instead, and they are quite big. By the way, it looks like that those displays were also used in the old James Bond movie. I mean, they definitely look very nice and very unusual. If you go to AliExpress, you can buy clock that uses a very similar Edgelit displays to show the time. And there are a lot of different designs and a lot of different styles. But what's common for all of those is that each acrylic panel has one single digit, and if you want to switch between different digits, you always light up only one of those panels. And in a way, that's quite similar how the Nixie Cube displays work. If you compare it to my display, I have a 7-segment design and each panel has one of those segments, so if you want to show a digit, you have to light up multiple of those panels at the same time, in the very same way how the standard 7-segment display works. And this solution has both advantages and disadvantages. The advantage is that there is no overlapping of those digits or segments. For standard Edgelit displays or even for Nixie displays, the digits are usually very thin to make sure that the digits on the front will not cover the digits on the back. That's not an issue in our case, because the same space will not be shared between multiple segments. The disadvantage is the viewing angle. Since we have multiple panels light up at the same time, you have to look right from the front to see the segments perfectly aligned. If you tilt it a little bit, they will not be aligned, and if you tilt it too much, you might not be even able to tell what is the current digit. So let's create this display, and for that we will need four different parts. We need the acrylic sheets, and we need some LEDs to light up those sheets, and we of course need something to hold this together, and of course we need some kind of microcontroller to control which of those LEDs should be shining and which should not be shining. Let's start with the acrylic sheets, because if you again go to AliExpress, you can get those in many different sizes and thicknesses and even shapes, which means that you don't need to cut them by yourself, which is great. I ended up getting this size, which is 5 by 7 centimeters, about 2 by 2.7 inches, and it looks opaque, but it's only because there is a protective foil on both sides, so if you remove the foil, you will have fully transparent acrylic sheet. And before I start engraving those sheets, let's talk about how we will light them up. In the original video, a custom PCB with white LEDs was used, and I was thinking about doing the same thing, but then I realized that I have a lot of LED matrix displays and perhaps I can use one of those. I have used the common 8x8 LED matrix display in many of my projects, including this YouTube counter, or for example this wooden clock. And I was also experimenting with changing the shapes of those LEDs. But while this display is very easy to use, it's perhaps way too big. I was also testing this display, which has 8x16 LEDs. But I kept searching and realized I have a lot of those NeoPixel LED Matrix displays. And obviously the standard 50/50 package, being 5x5mm in size, is way too big. But you can also get NeoPixels in smaller sizes, going all the way to 1x1mm. I think maybe it's 1.5x1.5, but anyway, still being quite small. And I have those two displays, which has those NeoPixels in a slightly bigger size, being 2x2mm. But I think it's still small enough to be usable for our project. And of course the main advantage of using NeoPixels, the individual addressable LEDs, is that you only need one data line to control as many NeoPixels as you want. But just before soldering those connections, I have found this board, which is not just the 8x8 NeoPixel LED matrix display, but it also includes the microcontroller, being the ESP32S3. And having everything on one board should simplify our project a lot, because we don't have to do any soldering or solve any connections. We just need to connect this board to PC using the USB-C cable, so let's do that. And if I press the boot button, there is some default sketch that's lighting up all the individual LEDs. And after a while there is only one LED being lit, and you can move this LED around by just tilting the board. And that's because there is also the IMU unit, the accelerometer and the gyroscope unit being included on this board. And if you are thinking, well, you can use this for your shift-turn-up project to get the current gear, yeah, that's definitely something that I'm looking into, but for now, let's focus on our transparent display. And let's try to create some sketch that will light up one row at a time, so we can test it with our acrylic sheets. With the board still connected, I will jump into the Arduino IDE. And here I need to select the correct board and correct microcontroller. And if you have never used the ESP32 boards before, you have to go to File, Preferences, and open the Additional Boards Manager URLs. And make sure to paste this URL in here. And once you do that, you have to go to Boards and type in ESP32 and install the ESP32 by Espressif Systems. And since I have this already installed, I can go to Tools, Board, and select one of the ESP32 boards. And let's actually open the documentation to see which is the right board. And if I go to Working with Arduino section, you can see that it shows us the steps to install the Arduino IDE and then install the ESP32 boards, which we have already done. And if I scroll down, there is this screenshot which shows that we should select the ESP32S3 dev module. So you can go to Tools, Boards, ESP32, and you don't see my menu because it's all the way on top, but it says ESP32S3 dev module. I believe you can also go here and select this menu item, and in here search for ESP32S3 and select the ESP32S3 dev module. And since I have this already connected to my PC, I believe the port is the last one, which will be COM number 18. Click the OK button. And then we have a lot of different options for this board that we can choose, but thankfully there is a screenshot in the documentation as well. If I scroll all the way down, this is the settings that we should be using. So just make sure that the preferences are matching this screenshot. I believe the things that were not set by default was the flash mode to be QIO 80 MHz, the flash size is 4 MB, and then the PSRM should be disabled. And then I believe that all the other settings were set to default, but it's again worth the time to just check every single item. Now to control the NeoPixels, the RGB LEDs, I will be using the Adafruit NeoPixel library, and I think that it's even mentioned here in the documentation, again working with Arduino. I think it mentions installing the Adafruit NeoPixel library, so I'll go to Libraries and typing NeoPixel, and that's this library, Adafruit NeoPixel. I already have this installed, maybe not the latest version, but I think that should be fine. And then I will open some of those examples which comes with this library. So go to File, Examples, Adafruit NeoPixel. And I know that this trend test is just like testing all the possible colors and stuff like that. So I'll open that sketch. And before uploading it to the board, I need to do few changes. I need to set how many NeoPixels I have. And I have 8x8, so 64. So I will set the LED count to be 64. And then I need to know to which pin are those NeoPixels connected. And while it's not specifically mentioned in the documentation, if you take a look at this piece of the code, you will see that the pin NeoPixel is set to pin number 14. So let's set the LED pin value to be 14 as well. And let's try to upload it to the board. And after a few seconds, we should see the demo sketch running on the board, lighting up those LEDs with different colors, going over this rainbow effect and so on and so on. So it seems like that everything is working as expected. Let's just try to make this sketch much more simpler by just lighting up individual rows of those LEDs one at a time. And while this trend test is nice, let's maybe start with something even more simple by going to examples, Adafruit, NeoPixel, and maybe select this one, which is simply called Simple. And it looks like that all this sketch is doing is just lighting up those individual LEDs with some green color. So again, I just need to set the pin to be pin number 14 and number of pixels to be 64. And I can again upload this to the board by clicking the upload button. And now the display starts filling with color, but it's not green color, it's actually red color. So it seems like that the color channels are somehow being swapped. So let's go back into our sketch. And instead of initializing the display to be Neo GRB, so green, red, blue, let's try to use RGB, so red, green and blue instead, and see if this will fix the issue of showing the red color instead of green color. And sure enough, now the display is filling with green color as expected. So once we have this small issue sorted out, we can change the sketch so we will be lighting up those rows one at a time and maybe use a white color. First of all, I will simplify the sketch even more and delete the stuff that doesn't need to be there. And then I will create a new variable and let's call this current row and set it to 0. And inside our main loop, let's increase it by 1. And if the current row is bigger or equal 8, we will set it back to 0. And then I guess I will keep this loop, but I will only go between 0 and 8. I will set the pixel color to be white, but not going all the way to 255 and 255, but maybe some smaller value, so it's not that bright, for example 150 for all the red, green and blue channels. And the index will be I going from 0 to 8, but I will also add our current row index, and since there are 8 pixels on each row, I will multiply it by 8 like so, and move the show function as well as the delay function outside our loop. So we will first set which row we want to light up, then we will clear all the pixels, so no NeoPixels should be shining, then we will set the corresponding row to white color or just some gray color, but it will still be white because it will be shining quite a lot. Then we will show it on those NeoPixels and then wait some time, and I think that the time is set to 50, which is half a second. For some unknown reason, I have to go to Tools, Port and select the correct port before every upload, so let's do that and click the upload button. And after a few more seconds, the display shows those individual rows being light up one at a time. And even when we are not using the fully white color, it's still being bright enough. Actually, it's very bright. So I think that for now, this should be enough for testing those LEDs, this display, but obviously testing the LEDs is quite hard with having the empty acrylic sheet. So let's engrave something on the acrylic panel, and there are many different ways how to do that. You can use the CO2 laser, like for example this Xtool P2, which I don't have yet. I mean, I would like to get it someday, but for now, I think I will skip this option. So I was looking at other options and found that this CNC router being the 3018, but there are just so many different options, I wasn't sure which one to get. So I just ended up using much more simpler solution and also much more cheaper. And that was getting this weeding tool set because it has this tool, which is pretty much just a simple needle for etching the surface. I've tried to engrave the 7-segmented display design without any reference and it kind of looked horrible. So instead I printed the 7-segmented design in the same size as the acrylic sheet and used that for my tracing. As you can see, I printed a few different versions in different colors and I ended up using this gray background with the black foreground color. And with one segment being engraved, I can put it next to our display and wait for it. Now it's nicely shining. So before engraving the other 6 segments, I think it would make sense to create something to hold everything together. And by something, I mean some 3D printed piece, and before 3D printing it, we have to of course model it and create it first. I will be using Fusion 360, actually it's just called Fusion now, and I will start by creating a new sketch on the floor plane. So click the floor plane, and as a first step I want to create those walls, those dividers between the NeoPixels. So I'll go to create rectangle and center rectangle, and the width of the board is 25 millimeters, but I want to do it all the way for all the acrylic sheets, which are sized 50 millimeters. And I've actually measured that they are more about 51 millimeters, so 51 millimeters for the width. And the spacing between the NeoPixels is not listed on this picture, but I've measured this to be 0.6 millimeters. Obviously, I need more of those walls, so I'll select everything and go to create a rectangular pattern. I want 9 of those for the y-axis, and I will set the distribution to be spacing, and the distance between those is 2.75, and I wanted this to spread to both directions, so set the direction to symmetric and click the OK button. I will create one more center rectangle that will go from the center, covering all those walls, so going to this edge, and then I will select the offset tool and offset this rectangle to outside to some amount, for example -1 millimeter. And that will be like the wall that will be holding everything together, so like outside of this board, there will be like this one additional wall. So click the finish sketch, and we can extrude it by selecting the extrude tool and selecting those individual thin walls, as well as the outside wall, and let's maybe extrude it to like 6 millimeters or so. Now to have a better overview of what's going on, I will right click the body and select appearance, and select some brighter material, for example the aluminum satin, so everything is much brighter, and then I will go to inspect, section analysis, and create a new section analysis on this axis, so I can easily see what's going on. And of course the idea is that the board will be laying flat like this, and those individual NeoPixels will be in between those thin walls. And to make sure that the board is not moving anywhere, I think it will make sense to also extrude this outer wall, and that will hold the board in place. So I will show the sketch again and show it from the bottom. Then select the extrude tool and select this outer wall and extrude it to -8 millimeters. So now if I hide the sketch, you can see that we have a nice place for our board to lay flat on. But if I don't show the section analysis, you can see that we have this USB port and we don't have the hole for the USB port, so let's actually do that. I will jump back into our sketch and double click it to open it, and then create one more center rectangle and go from this point, and I've measured the width to be 9.5 millimeters. And the height could be pretty much any value, for example 2 millimeters. Click the OK button and finish the sketch. And then I will rotate it to see the 3D model like so. And right click this extrusion and select edit feature. And then unselect this rectangle, so this is not being extruded. And that should give us the space for the USB port. Now if I show the section analysis again, we have a nice space for those LEDs, so let me just maybe flip it around so we can see how it will be positioned. So down here we have a nice space for those LEDs and the board itself, but up on top those gaps are probably too big for our acrylic sheets. And if I measure the size by going to inspect, measure, and measure the distance between, for example, this line and this line, you can see it's 2.15 millimeters, but the thickness of our acrylic board is only 0.8 millimeters. Which means that I need to make those gaps a little bit smaller. I will again create a new sketch by selecting the Create Sketch button and clicking on the top plane, and maybe hide the section analysis, and I will create a new rectangle from center, so center rectangle from the center, and I want the size to be 2.75, which is the spacing, minus the size of our acrylic, which is 0.8, but let's give it a little bit of breathing space and increase it to, for example, 86, and as for the width, it should be 51 millimeters. Then I will again select everything and go to create a rectangular pattern and use pretty much the same settings. So 1 for the x-axis and 9 for the y-axis, with the spacing being 2.75 going for both sides. Click the OK button. And I think that this is all that we need. So I'll click the finish sketch button, show our 3D body and maybe the section analysis as well. And then rotate the view so I can see it from the side like this. And you want to again extrude some of those pieces, so select the extrude tool and click on all those individual segments. And I will extrude those downwards to maybe -3 millimeters. Make sure that the operation is set to join and click the OK button. And now we should have enough space for those LEDs, but at the same time it should be small enough to fit our acrylic sheets on top. So I guess we can do a test print, and I usually just right click the body and select Save as Mesh and save the mesh. But someone suggested that I should select the file and 3D print, and since I've already selected the Bamboo Studio as the application, I can just select the body and click the OK button, and that should start the Bamboo Studio, and open the file in there. I'll just move it more to the center, and I want to rotate it. I can do it by clicking this rotation button, but I can select this auto orient, and that should flip it as well, because it will somehow find out that it should be oriented this way. I will keep pretty much all the default settings using the 0.4mm nozzle and the textured PEI plate. Since this is a test print, I will go with some random color, for example using the gray one, which should show us a lot of details, and then click the slice plate button, see if there are any obvious problems, which I don't think that there will be any. So all that's left to do at this point is to just click the print plate button. And once I click the send button, it will send the file to the printer and it will take about 20 minutes to print it. For 3D printing, I'm using the A1 Mini 3D printer from Bamboo Lab. It has the AMS unit, which means that I can use up to 4 different filaments at the same time or simply switch between those very easily. And it also has this live webcam stream that you can view inside this application on or your phone using the dedicated application. And it looks like that our print is almost done. So the print is complete and it looks very nice. I can fit in the board and I can fit in those acrylic sheets. Actually, I only have one sheet for now, but as I place it inside and the light is shining from the bottom, it's nicely glowing. Now before engraving the other acrylic pieces, I would like to do a few small tweaks to the 3D printed part. First of all, the board is only held on 2 sides and it's wiggling a little bit, and I think that if we hold it also on the left side and on the right side, it should snap nicely inside and not move anywhere. The second thing is that there is really no stopping point for those acrylic sheets. I can push them inside as much as I can, and while they will eventually stop on the board itself on those LEDs, it might be hard to align all of those to the same level. So let's jump back into the Fusion and make those small tweaks. Let's start with the area for the board itself, and for that I will view our model from the bottom, like so, and then create a new sketch. So click the new sketch button on this bottom plane, so on the bottom of those extrusions, and I will just draw the size of our board by selecting the rectangle, center rectangle, and it is 25 by 25 millimeters, but I will make it slightly bigger, being 25 by 25.5 millimeters. And I will finish the sketch and show the 3D model. And since I don't want to extrude this part, but the other part of the model, I will open the sketch again by double-clicking it, and then draw one more rectangle, being the center rectangle, in the size being 25 by 51 millimeters. Click the Finish Sketch button, and then we can use this extrude tool to extrude this part and also this part by 2 millimeters, which is the thickness of the PCB. So now the board with the display should snap nicely inside and it shouldn't wiggle around. Then I want to extrude some parts inside to have some stands for those acrylic pieces, and for that I will again show the section analysis and maybe right click and select edit to move the section analysis a little bit around, like so, because I want to extrude those small parts, and this way it will be very easy to select those. So select the extrude tool and select those small pieces and extrude them by 1 millimeter, like so. And if I again edit the section analysis and move it around, so those are the stands for those acrylic pieces. And here are the holes for those LEDs, for those NeoPixels. I just need to do the very same thing on the other side of the model. So click the flip button to show the other half of the model and move this around. And then I will do one more extrusion for those pieces, again by 1 millimeter, and that should be all that we need. For the final model, I've made a few small tweaks. One of them is visible when I show again the section analysis, and I've used the fillet tool to make the transition between those bigger holes and smaller holes a little bit more smooth, hoping that this way the light will spread out more evenly, but I don't think it makes any big difference. And then I have used the fillet tool to make the outer edges a little bit more rounded, and also the edges around the USB port. So let me just zoom into that section. I've also used this fillet tool to round those sections. And this is pretty much the final version of our 3D model for the stand for the acrylic pieces and the LED matrix display board. Let's show the section analysis one more time to make sure that there are no problems, because they will be quite hard to see from the outside, since all the important pieces are inside our geometry. And since I don't see any obvious problems, let's 3D print it again by going to File, 3D Print, select our body, and click the OK button. That will open the Bamboo Studio. I will again click the Auto Orient button and then click this Arrange All Objects button. And this time for the final print, I will select this PLA metal material. Then click the Slice Plate button, quickly see how this looks like, and then click the Print Plate button and click the Send button. With a little bit more details, this print takes about 25 minutes to print. What I haven't told you that out of those 25 minutes, the first 5 minutes are used for all the calibration, the auto bed leveling and stuff like that, which means that the print actually takes only about 20 minutes. So let me speed it up for you and wait a few more seconds. This is how the finished 3D print looks like, and I've actually printed it in a few different filaments, being this PLA metal, which is this grayish black one, and then I have this one, which is the PLA matte black. And while the difference is very subtle, I still like the PLA metal material a little bit more. So now it's finally time to engrave all those 7 individual acrylic pieces with different segments. To make things faster and easier, I've 3D printed this stencil. Actually multiple stencils also for the hatching inside. And again, I'm using this sharp needle tool just because I already had it. But you can also get like the proper engraving needle tool, and that will be also quite cheap, most likely even cheaper than this tool. By the way, this brand, the Cricut, is making like the vinyl cutting machines for home use. There is also a second brand called Silhouette, which is making pretty much the same machines or very similar machines. And I have one of those machines, but I just found out that they made a new machine called the Curio 2. And that one is supposed to be able to cut not only vinyl and paper and stuff like that, but also engraving acrylic with a proper tool. So again, there are a lot of different machines for engraving acrylic. Unfortunately, I have none of those. I only have the diode laser cutter, and that will not cut or engrave transparent acrylic. But enough talking, I have all my 7 pieces engraved, so I can put them inside the holder one by one. And then of course I will place the display board from the bottom and snap it inside. And once I provide the USB power, those segments will start lighting up one by one. However, to show a digit, we need to light up multiple segments at the same time, which means that we need to update the sketch inside the Arduino IDE. I will make it as simple as possible, and for that I will create a new function that I will call setSegment, and that should light up one row, so I will set the segment variable, and inside that function I will just copy and paste this for loop with just one more change, and that is changing this current row to be the segment variable. And that's pretty much all that I need, so I'll delete the current row variable because I don't need it anymore. And then inside this for loop, I will go over every single row. So first set of the pixels to be off state. Then I will call the setSegment function with the index of y, and also include the pixels show function as well as the delay. And this code will do pretty much the very same thing as our previous code, but what we can do now is, for example, say that we want to light up all those segments and keeping the previous ones still being lit, so I'll just move the pixels clear outside of this, and this loop will go over every single row and light them up one by one, while this one will do the very same thing, but it will keep the previous rows still being lit. So let's quickly test it with our board. Again, I have to select the board every time I want to upload the new code, and then click the upload button. And now we see a new sequence, and it's of course quite important in which order we insert those acrylic sheets. There is a common way of referencing segments on the 7-segment display, starting on the very top and then going clockwise and ending in the middle segment, which is the order that I have used, which means that I just need to light up the correct segments to show the digits. And I will do this in a very manual way. After this demo sequence, I will clear all the pixels, then set the segment 0 all the way to segment 6. Show those segments and then wait a while. And based on which digit I want to show, I will just comment out some of those. So this will be the digit number 8. For digit number 0, I will comment out showing the segment number 6. For digit number 1, I will not show segments 0, 5, 6, 4 and 3, only showing segments 1 and 2, and so on and so on. And with having the code for every single digit, we can again upload it to the ESP32 board. And that's it. Now we can show any digit or any combination of segments, whatever you want to display. I like that when you look from the top, you can see that which of those segments are light up and which are not. And I also have this version which doesn't have any etching inside, and it still looks very interesting. Now we have 7 segments, but we actually have 8 rows on the display board, which means that we have one empty slot and you can use it for whatever you want, either being your logo or maybe the decimal point. Yeah, that's up to you. Also, those NeoPixels can display any color you want, so it doesn't have to be just white color. It could be really anything, and you can even try to use different colors inside one row to see how it looks like, but that's something probably for the next video. For now, that's all I have. All the source files are on GitHub, the link is in the description. If you have any questions or comments, or if you maybe create your own version of the display, please let me know in the comment section. Thank you very much for watching, and I hope to see you soon. Thanks and bye.